Hi, welcome to another stream of long silences and awkward pauses. Last time we were, we finished soldering most of the things on. Most of the things that we're actually going to put on for now. There are some push buttons and LEDs that we didn't put on. The second FTDI and the big VME connector. We had things kind of working, sort of, but not really, with some things. There was some activity, or what looked like activity, but the CPU wasn't running code, and the FTDI wasn't responding. It wasn't enumerating, so we couldn't actually access it. Since then, I washed the board off after the last stream, and let it dry for a day and a half. And this morning I was playing around with it and plugged in the USB to the FTDI, and it was enumerating. So I had, just before the end of the last stream, before I packed all my soldering kit up, I reflowed the FTDI chip just in case that was a problem. And maybe that was what got it working, or maybe it was just something else, the water or something that hadn't dried yet or something, but it's working now, so there's that. So we can access it. I've tested it. I've looked at the serial coming out of it on the other side. We're getting activity coming from the CPU, so I'm confident that's working. And then it was kind of a matter of turning to the CPU and the CPLD. So with this board, unlike previous boards that I've made, there's a programmable logic chip here, the CPLD, which is largely connected to the control lines of the CPU and to various other things. The select lines for the RAM, the select line for the ROM, the control signals for the transceivers. It does not have access to the data bus and stuff like that, but it does have access to the address lines so that it can do address decoding. My suspicion is that the CPLD program, which I did not test, which I just quickly hacked up something and loaded it in, that there's probably a mistake there. So if you can see, I've put a couple of resistors into the socket of the CPU. I have a pull-up on the address strobe and a pull-up on the data strobe signal. So to the CPLD, those are just inputs. So with the CPU out of the socket, as it is, CPU is here, chips are here. With the CPU out of the socket, nothing would be powered, those signals would be 0, and the CPLD would think that it's in the middle of an access. So it's kind of like, well, what's going on with the CPLD? So I'm gonna turn my power, my scope on, turn power on here. Our inrush is much better now as well, so could be just like washing the flux, like reflowing some things, washing the flux off, letting the board dry. That might have fixed some of our issues. So board is powered. We're at like 200 milliamps. Oh, I wonder if, let me quickly check that. I didn't have overcurrent protection on because it resets every time I turn the board on. We were fine. We started up without an issue. We're not seeing that huge inrush that we were earlier, so maybe it'll be different once we get the chips in, but right now it's fine. It's mostly the bypass caps that cause the inrush. I'm not limiting the bypass caps, so I have overall a fair amount of capacitance that's just across the line. So also my probe is kind of acting up a bit these days. I should replace it. So that's the data strobe line. We're high and just short it out. That is the address strobe line, which are pulled high. And if I look up here, I know that these first two signals on this resistor network are the data acknowledge signals. So this is not the data acknowledge signal. That's just a pull up. That's a S term, if I'm remembering correctly, and this would be B air. So those are being pulled up, but data strobe 0 and 1 are low. So that means those two signals are controlled by the CPLD. And let me change the view here. So this is the Verilog for the logic. And I threw in some stuff just here for controlling the data strobe. Normally it would be controlled by the VMEbus logic block that I made, but I have that disabled right now just because I don't need it. I want to eliminate variables, so removing that so that we're just looking at the address decode and the control signals for the RAM and the ROM chips. That should be enough to boot the CPU and get the ROM running. The ROM contains a monitor program that I wrote previously for a previous board, a very similar board. So my hope today is to just get the CPU running, executing code, executing the monitor, talking over the FTDI to the computer enough to communicate over serial. If the monitor is running correctly, there's a commands in the monitor so that you can load a program over serial into the RAM and then jump to it and execute arbitrary code. So I don't have to actually reprogram the flash chip, this flash chip here, in order to change the program. So if we can get to that point, then it's just a matter of getting the bus and the VMEbus stuff working. And I'll leave that for another day probably. So I'm just trying to get the CPU running and executing code. So clearly right now, we're giving it address strobe, we're giving it data strobe, sorry, they should be inactive. So we're pulling them high, they're active low. So we're pulling those too high. We should not be requesting an address. Our CPLD should not be pulling the data acknowledge signals low. Those should be high. But that's not happening. So we've probably got a problem with the program. So, and I was looking at this the other day, this morning I should say, the other day. And clearly there's a very glaring problem that I can obviously see. In order to help with dealing with active low signals, I have two parameters defined here for active, which is 0, and inactive, which is 1. But here I'm just saying request RAM as if it's true, which it's not the case. The address decode stuff here controls the request signals that come out of the CPLD, and I'm using inverted logic for these signals as well. So request ROM will always be inactive, so technically this code here is going to be returning true. But we don't want that. So if we just change this a little bit. So DSAC is going to be high impedance. The 2 bits of DSAC will be high impedance if nothing else is evaluated in this block. Oh, this is an unclocked block. Hopefully that's not a problem. We will see. So if this should be active. If request RAM coming from the address decode logic is active, then we will respond with 2 bits low, because our RAM is a 32-bit port. So the DSAC is not related to the size of the access that is being requested. It's related to the size of the physical port. So that determines what data bus pins the data is expected to be on. If it's a 32-bit port, then it would expect that the 0th byte would out of 4, the address mod 4 would always be on the upper address lines, because this is a big endian CPU, so it would be on the data lines 32 to 24. If it was mod 1, then it would expect that byte to be on data lines 16 to 23. If it's mod 2, it would be then 8 to 15, and if it was mod 3, it would be always on 0 to 7. So for the RAM, because it's we've got two 16-bit RAM modules here. the two RAM chips are connected to the upper 16 and the lower 16 bits of the data bus. So it's always going to be a 32-bit port, no matter what size transaction you request. This is one of the really convenient things that the 030 does compared to the 68000, the original. And I believe the 68040 changed the bus interface quite a bit as well. It has like transactions and stuff, and there is synchronous. This CPU also supports synchronous memory transactions, but I'm using the asynchronous interface at the moment. So the DSAC can actually is the mechanism by which different sized devices can interface to the bus without having to shift their bits to different parts of the data bus. The CPU will know that if the acknowledged signal is the 32-bit signal, that it would expect the data to be on the appropriate data pins out of the full 32-bit data bus. If it is in the case of the ROM and the serial, which are both 8-bit devices, only the lower acknowledge pin goes low, and that signals to the CPU that it's an 8-bit port. Only the data on the upper part of the address bus or the data bus. So this is pins 24 to 32 of the data bus will ever have valid data. And if it's trying to access like a 16-bit or a 32-bit value, it knows that only the 8 bits on the upper part of the address bus will be valid, and it needs to do another transaction in order to get the rest of the data that it needs. So previously we had the wrong logic in there. It was not going to be working. Now it's going to be if the address decode logic is saying that the RAM has been selected, it'll go low, which is our active parameter. So if it is active, then we will acknowledge the signal immediately. We're not giving a delay. You could give it a bit of a delay of a couple clock ticks before it actually responds. But in this case, I happen to know with the 030 that if the acknowledged signals go low, as soon as the request comes in, the CPU will still take like 2 clock cycles to actually respond and read in the data. It's basically going as fast as it can. So you're getting no wait states essentially, which should be all right. We are just running at 12.5 megahertz clock speed for the moment. So we should be fine. So we would expect this to work. Let's try programming it. See what we get. compiled fine, it looks like. Start up our virtual machine so that we can program this. This is kind of annoying that I have to do this, but these ATF 1508 CPLDs are very old. The software has not been updated since like 2007 or something. And even then it was like a rough port. I've managed to find a project that sets up Yosis to compile Verilog for these chips, so I don't actually have to program it with WinCouple, which is a horrible program and I never want to touch it again. But I still have to program the device with this, and Wine doesn't work because Wine doesn't properly emulate USB devices, so let's see. Okay, it's working. Okay. So now we would expect to see the data strobes to be low, or to be high. And they are still low. Darn. Why would they still be low? Let's take a look at the schematic here. So we have a reference on page 2 and 5. Oh yeah, for the serial I'm actually just going straight out to the DSAC signals. So I don't actually need to use the CPLD to do acknowledge for the serial port. I just need to do acknowledge for other things, the RAM, the ROM, and the VMEbus. Well, I mean, we're getting both of them are not being pulled up. So like, that's S term, that's DSAC 1, that's low, and that's DSAC 0, and that's low. So we would expect, we don't have a chip in there for the serial controller anyways, but we would still expect them to be high. And I don't think there's anything else that is pulling it low. So you see it's just going, I forget what that command is to just make the editor only show one set of traces, but there's not much to it. It's just being pulled up. It goes to the serial socket and it goes to the CPLD. So the CPLD must not be actually doing the right thing. It's possible it could be related to the fact that we're just using an always block instead of a clocked always block. What if I tried that? So we would expect it to just be in high impedance state, which should mean that the pull-ups can pull up. Now that I think about that, like, let's maybe just quickly verify that it is soldered correctly. So if I go into that pin, yeah, that's the high side of those pull-up resistors. So that's high on the chip. So it's definitely going to be pulling it up. There's something else that's pulling it low. So let's try this program. I'm just putting my fingers on these transceivers to see if they're getting hot. They're not cold, but they're not burning up either. So I assume the bodge that we put in to it's easier to raise the board than to lower the camera. The bodge wires we put in for the pull-ups of the output enables. So while the CPLD is being programmed, those outputs are high, are low because it's not being commanded to be anything, and they're active low. So the transceivers are on, and they were burning up quite a lot, which might have damaged them, but we're not using them for now. We just want them to not get even more hot and potentially die. So we are still seeing lows on these. Did I did not make that proper. This should be in out. Right? Oh, that was in out. I'm just confused. I can't read properly. So that is in out and not input. We should be able to do the high impedance state. When they're in high impedance state, they should be pulled up. There should be nothing that's commanding them. What if we try just output high? Should work. Oh. Our logic didn't compile the last time. Okay, go back. What went wrong? Did this actually... Yeah, okay. So the unhelpful error that we get here, that please contact your hotline, is actually because of this warning here, which says that it's not being driven and therefore it's being left unconnected, and because it's unconnected in the output, the fitter that runs after it is not happy. So we can't just output high impedance, because the Yosis just won't actually connect them to anything. We should be able to drive them to 1. Okay, so that worked. I just want to make sure that there's not like some electrical issue that is preventing this from actually getting pulled up. Here we go. So that does work. Probably doesn't make a difference, but might as well try that. Does compile? Yeah, they're still low. What if we make it clocked? Does it complain about something else? Signed in a block? I wonder if that's our problem. Yosis is like this, where it doesn't give you errors. It just says, oh, it's probably not right. I think it's a warning. And then compiles anyways. In my previous testing with the CPLD to make sure that it was even possible to do whatchamacallit, high impedance outputs, a tri-stated output, I was having it do an assign instead of assigning in a block, because usually if you're assigning in a block, you have to have a register, but I think you can't have in-out with a register. So we might have to like interpose it to get this working, which is not a big deal. Yeah, see, we're getting nothing, so it's probably the assignment and the fact that it's not a register. I mean, I suppose I could try it. Let's undo that one. You know, Reg, does it complain? Well, it's only 16 warnings now. It did something. This isn't a problem right now because our chips are out, so there isn't a risk of like conflicting with the serial port controller, because that's the main reason why we need to tri-state these instead of just having the CPLD output constantly, is because the serial port is also using these signals. All right, where are we? That is still not working. I mean, since the chips are out, I suppose we could, like, you know, do that. Instead of doing high impedance, we would do $14 warnings. Now, I would expect this to work, but it's not gonna do what we want it to. There we go. It was in the middle of programming and I wasn't paying attention. Okay, yeah, so they are high, as we would expect, because we're just doing the right thing here. But we're gonna have to interpose, so... We want it to come out of the, like, normally what you would do is like, enable equals something, or high impedance. But I have it as 2, but we kind of want them to actuate separately, so we could have 2 assigns, 1 for each one. And then we could just do the CPU DSAC out. If out is true, then, well, so the idea there would be we can just, our CPU DSAC out would be what we're requesting, and when the CPLD is requesting that be driven low, then we drive it low, otherwise we're in high impedance. And then our DSAC in our block here would be the out version. And we could just make those 1. Oh yeah, I just had a thing. So if this works, we should get 14 warnings instead of 16 warnings, or some other different number of warnings. We get 16 warnings, so I'm kind of suspicious that it's not going to work. I don't know, it's not complaining about it. Like, this is the start of it. It's complaining about the tri-state because it only has limited support for a tri-state, but it does work. I have gotten this working before with example code, but I specifically have used this pattern. I mean, we could just try it. There we go. Our DSACs are high. Okay, so I think that's working. We'd like to actuate it. And if, I don't know, I assume with the CPU out of the socket, we're gonna read zeros, so we're gonna be addressing 0. So if we just actuate the address strobe signal, we would expect to see the ROM select signal come in. So let's check out the ROM cell. It's pin 22. It's always hard to get on that. It's gonna be this. That one? No, that's, so this is the clock. The one next to it is RAM cell, and the one next to that, if I can see that, would be ROM cell. Do I need to remove both of them? Neither of those seem to have, wait a minute. They're both low. They're not supposed to be low. They're supposed to be high. God damn it. God damn. Okay, let's put my horrible little jumpers back in. What did I have it at? Data strobe is the fourth one up on the second column. Going there. And address strobe is the one just above it. I keep shorting out on the collar here. Okay, so our RAM cell and our ROM cell should both be high when nothing is being requested. Did I hook up the reset button? I don't think the CPLD has the reset. Oh, we do tie it in, but the logic is not using it, I don't think. It's not like a dedicated reset for the CPLD. I also want a better pin to go on. Like, I should be able to just do one on the connector, but I just don't know which one it is. Because, like, according to the bottom, it's pin 22, which should be that pin. That's interesting. It's a little... Is there maybe some conflict somewhere? Because it's a little offset. So that's pin 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. That's definitely not the right pin. Gotta be that one. No, it should be that one, right? Right, okay. So that's got that one is offset a bit. And those are the data pins. Which probably means that our RAM, both RAM chips, well, both RAM chips are on different data pins, but maybe one of the transceivers is? I don't know. I thought that one was gonna be R2. I keep touching the board and then feeling like some heat somewhere. Always frightening when there's heat, and I don't think there should be heat. Okay, so our DSACs are high. And it's pretty much just these two blocks. I expect this to not do anything. So we would just be here. And we are doing an assignment in a non-clocked block. The VME request signals that you see here, the request VME A16, A24, and A40, they are internal signals, so we wouldn't be able to see them on the outside, but we would be able to see the request RAM, request PROM, and request serial. Those should all be high, and I'm pretty sure they're not high. RAM cell and ROM cell, we've checked. We know those are low when they shouldn't be. But where's the serial one? IO cell. So if that's pin 1, and pin 44 is 5 volts. So 43 and 42 and then 41. So that's the second pin in from the top. And that... Oh, no, it's 39, sorry. Ah, shit. Okay, let's go back. So that's 44. 43, 42, 41, 40, 39. Okay, so it's the first pin on the right. And that's definitely high. Or sorry, that's definitely low. I say one thing, but my brain's thinking another. I'm sorry about that. Probably really annoying. And then pin 6 is our RAM cell. So 1, 2, 3, 4, 5, 6. And that is also low. So why the hell is it low? What if we take a hammer approach and just comment out this? Our output is output reg for these ones, so that's right, but I think it has to go all the way up. Oh, yeah. We just have those. Oh, we don't have... Motherfucker. Motherfucker. So those should be 16, 84, and 85. And we can see from this 84, 80. 85. 85 is the... That's not right. '85 is the CPU clock. 84 is RAM cell. 83 is ROM cell. 83 is ROM cell. So we're not actually like the signals aren't even going out of the chip. Where are our serial stuff? Right here. Our RAM stuff. Our the RAM DS signals. There's a one of four byte outputs which control which of the signals for the upper and lower byte of the two chips will actually like be active, but that's in addition to the RAM cell signal. So we need to make these outputs instead of here. Request serial, I don't think this would be IO cell. We do have an IO cell on 16. Right, because the address decode is doing that. but then the serial controller is handling its own acknowledged signal. Okay, I think that's all right. So request serial does actually need to be produced as well. But those signals are internal. Okay. It's always nice when you find something. Oh, what's that? DSAC is left unconnected. I didn't change anything. Oh, it's not working. And I thought I had thought the program was working, but it's not actually working. Okay, let's just get the select stuff that we know. So we're still not getting the DSAC stuff working. I'm just gonna start swinging hammers. I just want to see if it'll compile. No, it's not going to compile. It's not going to do what we want. Literal head scratching. I was about to say, oh, this works fine without having a logic or a clocked block. Not to be confused with cock block. Is it commenting out that's the problem? Yeah, that literally is the problem. Okay, fine. We'll keep it. Whatever. Sometimes Yosis can be annoying. Sometimes Verilog can be really fucking annoying. I really should try something better. So what happened was, because I commented out the logic that actually controls the request RAM and request ROM signals, it was correctly determining that that signal would never change value and therefore was removing a whole bunch of code, including all of the code that would have controlled the Excuse me while I futz about with other things. Getting back to this. The logic is compiling now. So let's try. Let's make sure. Okay, we are Let's try programming this again. My frame rate seems to be really poor right now. Not sure why. Just noticed it. That's unfortunate. That seems to be better. The never-ending issues with Pulse Audio. I had PAVU control, the Pulse Audio level controller application open, and that was causing that problem. Still have Pulse Audio running, still have my music playing, still using Pulse to get audio from things. Well, actually, I guess I'm getting it directly from the microphone, but just having the VU open seemed to be causing problems there. Hopefully it wasn't too bad. Hopefully it wasn't unwatchable or anything. I had a stream recently where the audio was really messed up, so I'm trying to be a little more cognizant of it. Alright, getting back to this. We put some logic in there. We expect it to do some stuff that's more like what we want. We are currently telling it that address strobe and data strobe are high, so we shouldn't be giving it the request to enable any of the logic chips. So we would expect 1, 2, 3, 4, 5, 6. That is the wrong pin. 1, 2, 3, 4, 5, 6. Is that the right pin? I mean, it is high, so there's that. That's the serial. That's high. And then, god damn, these things are like, they're not cold, but they're not boiling. Okay, looking on the back, we are definitely getting high on our request line, so we should be able to find it on the top here. That is it. Okay. Yeah, and these should all be low because they're just the data pins. Yep, so that is our request pin. So we are definitely not requesting anything. And according to our logic, it is right, CPU address strobe has to be active. We don't care about the data strobe. So that should now be low. Let's check that here. Address strobe is low. Our data lines are all, our address lines should all be 0 because they're not floating. But our request ROM is still high. Our request ROM is still high. Our request serial is still high. So it's specifically address pins 20 to 20, 23 to 20. I wonder if even our logic is just weird because we're doing this funny thing with the address lines. So I should probably change that and see. But we can also just quickly look at the address lines themselves. We're concerned with 23, 22, 21, and 20. So that's 1, 2, 3, 4, 5, 6 in a cluster. 6. That's low, that's low, that's low, that's low. Change that. What are you talking about? I might just not have make set up correctly. Oh, dicks. Well, this isn't gonna hurt anything to activate both of them at the same time. I'm just trying to get... Oh, God damn you. I'm just trying to get it a program that will work, that will just test this one thing to just see if with address strobe low that we do see the signals change. We want to see them change state. So let's pull back, pull address strobe high again. Address strobe is high. Our program is written. our RAM cell is high, or our ROM cell is high, our RAM cell is also high. And if we just disconnect our pull-up, our RAM cell is low, or sorry, our ROM cell is low and our RAM cell is low. Okay, so that is working. So it might actually be those address signals that are still not correct. Seems odd that they would like be high or like, I don't know, high impedance or something if they're not connected to the right things. So this is call it address high. Just to try and distinguish it. That's now high. Okay, so that's compiled. Our high pins are here. Reload our file and then program this. Okay, so they should be high. Not high. That's high. Okay. And that's high. And that's high. And I put my finger somewhere over here and felt some warmth. These still just feel so goddamn warm. This is just so wrong. There's gotta be a problem here still. I fucking hate these transceivers so fucking much. They are so fucking annoying to work with. They are the smallest pin pitch that I have to deal with. I mean, they seem the same or even bigger pin pitch than the CPLD. But Jesus fucking Christ, they're fucking annoying. And they just have so many problems. I've had nothing but problems with these stupid fucking transceivers. But I'm expecting to respin the board anyways, so gotta fix this. Maybe they're fried. We'll try some new ones. Maybe they just run hot. Who knows? All right, so there's our ROM cell, and if we pull the address strobe, we should see it go low, and it goes high again. Good. So that seems to be actuating correctly. We expect to not see RAM cell because we have it back the way it should be. So pull that out. Yeah. And we would also not expect the serial ship select. Okay. That's promising. I mean, we could try injecting an address, a different address. Here's another 10K pull-up. So it was, we want to, looking at the logic. Let's get RAM cell, so that would be 0, that would be address line 20, which is B8, which is the 6th one in from the side, and there's a 5 volt, sort of 2 over and 1 down. Right, so one, two, three, four, five, six. So that's being pulled high. So we would expect that if we pull address strobe, we should not see RAM cell go low, or ROM cell go low, but we should see RAM cell go low. We don't see RAM cell go low. That shouldn't be a problem, having that adjacent pin, which would be 22, be high. Fuck me. Jesus fucking Christ, this is annoying. Ah, so we have like nothing for that. It would, I mean, it's correct if it's mistaken. It's just to try and like pull down that other signal in case it was like there was some crosstalk that was causing problems. What pins are we on for the CPLD? Not 50 here, which should be disconnected. Why is it high? Oh, it's probably got something on it, but it's something else. Something I don't need right now. Okay. Let's try and get on that pin. Okay. That's low. That's low. That's low. That's high. I think. It is really hard to see these fine pins. That's the other address pin, so that's high, and that's low, and that's low, and that's low. Whatever that is high. And address strobe is low, and ROM cell is high, but RAM cell is also high. Let's double check our pins. "46" is 0. I'm pretty sure that's what we were on. Yeah. Okay, so this should be back to not requesting anything. And then it is this one we want to disconnect. And we should see nothing. If we pull that, we get weird stuff, but it is requesting the ROM because it's 0. If we were to add that back in, yeah, see, our ROM select is actuating based on that 1 bit. But we would expect our RAM cell, which is supposed to be that. Let's double check that. Yeah. That should be that pin. It briefly goes low. Let's maybe single shot this. Falling edge. Okay, so it does go low, it's just going low very briefly. seems a little odd that it would do that for the RAM cell, but not the other one. But it's probably working. What's our data strobes doing? Or our acknowledge signals? So that's low. Okay, so our acknowledge is working, or looks like it might be working. The only other thing is this RAM stuff. What do you think? Should we just throw the CPU at it and see if it like does something instead of nothing? It's entirely possible that the pull-ups that we have are just not gonna be strong enough because I've got a 10K pull-ups instead of I put 2.2K pull-ups on the other board that I did and 1K pull-ups on one of the earlier boards. Just for the data acknowledge signals because they are such a goddamn problem. It looks really ugly when the CPU's in. Yeah, I guess we'll just send it. It's getting late. And I didn't want to stream for very long. So let's also hope that I didn't damage things by poking pins in here. Power off. Just in case, I won't put the serial in. I'll put the It should still boot. I'm just like thinking through. If I don't put the ROM in, my concern is like if something's still broken, then and it happens to like have both active at the same time, which we kind of confirmed it's not doing that. But if that does happen, if I don't have the chip in, then that's not going to happen. It's not going to conflict with the RAM. We should still see something because it's going to read in 0 as the address to start executing code when it boots, and then it will start executing code at address 0, and it's going to be like a 0 opcode is like an immediate OR operation, immediate OR instruction, which should still do nothing essentially. It should essentially be a NOP and should just like advance through the pins. So we should see the address lines flickering. And our pins are just out of curiosity, where are are one. Oh, we don't have them. 2 is the lowest. Okay. So if we go on this pin, well, that's high, so it's being driven high. Okay, so we're still not seeing a lot of activity. We are doing a single byte acknowledge. So I think it is back to the DSAC issue. So we'll do a reset. Not seeing anything. Should be falling. Okay, that's going to be our address strobe. Yeah, it's not actuating. I was hoping I could get away without pushing the CPU right down into the socket, but maybe not. I also don't know for certain that the CPU is going to work at all. It could be rebadged. Probably need jumpers on these actually. pulling them to ground. Power off. Well, it's high. Single. Reset is not activating, is not changing the state of the address strobe, which to me is a little weird. Okay, let's go back to auto. It is requesting because it thinks it's, I mean, it is low. This is not a probe issue, is it? Power, power, power. There's power. That's pretty ugly. That's when it first starts. Address strobe goes high. Try and get some more time on here. Address strobe goes high and it doesn't go low. Well, not for a long time because it's still high. No, there, it goes low. That is just so weird. I would expect the reset button to actuate things. What if I put a bypass cap or a alternate size of pull-up on this? I want to isolate. Oh, that's wrong. We want high. No. So this should be high. Yeah. And put that on there. That's high. That changed it. Now it seems to be at least actuating that. We have some sloppiness, but that's just this probe being the way it is. Well, that's doing something. More than nothing. It is very messy. That's better. There we go. So that's doing some address accesses. So this is address strobe. I held the reset button and then I went into single step at that point. The rising edge is when the CPU comes out of reset. So the address strobe is going high, which means it's not activated. And then it's going low, so we've got 1, 2, 3, 4. 1, 2, 3, 4. So that's two 4-byte reads. Because it's reading 8 bits at a time because we're reading from the ROM, which is not installed right now. So it is actually like trying to do the boot procedure. Normally when the 68,000 boots, it reads in the initial stack pointer and the initial start location, the reset vector location, which are both 4-byte numbers. And then it should start and go. We don't see anything else happening here. So it reads those in and then stops. But it is reading them in. That means that our acknowledge is working. If our data acknowledge signals were not working, then it would get to the first one and stop. But the fact that it's signaling means that we are seeing a change on the data strobe signal here. So I wonder if I could catch that. Maybe I can't, because it seems to be not wanting to. It's almost like DSAC is low the whole time. Might help to have the ground lead hooked up. So we're definitely reading high there. We're definitely reading low there. We're at 10 microseconds, and we're not catching an actuation. That's kind of disappointing. We're not catching it here anymore either. Again, suspecting my probe might have an issue. And I probably should just change the probe. There we go. Just not seeing it. That's really suspicious. Yeah. Well, I'll just see if it does anything. Stick that in there. Stick this in very lightly. Or not. Oh, hi! Bitwelder, welcome. I always get too lost in what I'm doing to notice chat. I'm sorry if I didn't catch you. Oh, yeah. I need to pay more attention to chat. I'm sorry about that. But I am going to call it soon. I'm just going to see if this does anything quickly. So let's hook up serial. And open a terminal. Need to power on first. There we go. See the device. And nothing. Not surprising. Auto. There's our receive. So as I type things, I can see data coming through, and then this should be our transmit. And resetting is not doing anything. Try address strobe again. Okay. That doesn't seem right. I wouldn't expect to see that gradual fall off like that. That's I wonder. I'll pull this chip out. It is warm, and it, oh shit. Forgot to power off. Hopefully they didn't fuck it up. Yeah, still no activity. I should probably change my probe and stuff, but yeah, I might just call it here. Maybe maybe another day I'll come back and pick this up again. I could try changing the CPU, but I don't think that's gonna have much effect. I probably should like more thoroughly go through everything and just verify everything, but it's also really boring doing that. So we'll see how it goes. It it sometimes seems to be starting up and sometimes seems to be reading in the first 4 bytes, or attempting to read in the first 4 bytes, or 8 bytes, I should say, which is the regular startup procedure. But sometimes it just doesn't show any activity. Oh, there it goes, you see? Sometimes it does this weird thing, and sometimes it does the right thing. It's when I push it down, right? So when I push the button, it sometimes has that falling edge, which, I mean, some capacitance on that line, that's understandable. And then when I pull off, we get, oh, that's a lot more. Look at all that activity. Need to reset my serial. All right. Serial. Reset that. Single step. And once again, doing nothing. Oh, because the FTDI chip is not in, but like, that's okay. Or the serial port controller. But we should still see something happening here. And we are seeing nothing. Sometimes we are seeing something, and sometimes we're not. Why do you keep fucking with me? Why do you keep fucking with me? You were working. You were doing a thing. And now you're not doing the thing. You're not very nice. A little more consistent, okay. Single step. There we go. So we've got the first byte, the second, or the first long word, the second long word, and then so that's 4, 8, so 1, 2, 3, 4, 5, 6, 7. I mean, it gets through a fair number. And then stops. I would have expected a few more instructions before it tries to hit the serial port, but it could be the serial port that's causing, the serial controller that's causing a conflict of some kind. What are our Those are only used as inputs. These. We do have this serial IAC. The monitor does not require interrupts. So let's make serial IAC equal 1, which should deactivate it. All of these signals are active low, so it's possible that it was being told to do an interrupt cycle even though it wasn't supposed to, or it's like acknowledging it and then it's not responding or some weird thing. We need to pull these high as well. Maybe I should double check those as well. 96, 94, 93. 96, 94, 93, and serial IAC was on 19. 19 serial IAC. Okay. So let's try reprogramming the chip. Probably should have pulled the CPU out, but it should just be mostly inputs. Go back to our serial. Power off. Okay, we will close that. Stick our serial chip back in here. Power on. Connect to serial. No response still. So serial probably isn't working. Let us go back here. Single step. Wow. Wow. Okay, let's go back to auto. Oh, I touched something. There we go. It's like it's bursting. It is printing garbage. It is actuating. I keep touching the board and I need to not do that because it's fucking things up. Auto. So I'm on an address line, and every now and then it blips, and it does some stuff. We can see that the LED is coming on every now and then. So it's transmitting some data. You see there, that's address line 2, I think it is. So it does a thing, and then it stops. And it's doing the wrong thing, like it's printing the wrong stuff out. Oh, ha 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 ha, ha 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 ha. I'm on the wrong speed. 38,400. Welcome to the 68,000 monitor. And it doesn't respond, and then it sends it again. So it's actually running. It's running code. It's just getting to something and then locking up or having an exception or something, and then it's resetting. So we are running code. We have succeeded. We have made progress. Yes, Helena, we have made progress. This is amazing. We are like 98% there with the basic running code. The monitor isn't working. It keeps resetting or something, or I don't know what exactly, but it's doing something. It's running for a bit and then it dies. So we could still have a logic problem, but at least our ROM is working. Our RAM is probably working, because I don't think it would be able to boot without RAM working. Because it would be calling functions. There's a few functions that it has to call and return from in order to get far enough to print the welcome message from the monitor program that's on there. I just don't know why it's dying. But we'll leave that for another time. I'll probably take it chill this evening, so I don't know if I'll work on this much more. Maybe I might hook it all up and see if it does a thing still, if it still does this, but I might also just leave it till tomorrow. Yeah. Thanks for joining if you did. I hope it wasn't too boring. I'm sure it was quite boring. Just futzing around with things. There were a few logic problems. We changed some things, rewrote the program into the CPLD, and we now have it working 98% there. We're running code on the ROM. We're able to read and write at least somewhat to the RAM, and the serial port controller is doing something and sending to the FTDI. The FTDI is working. It's receiving data from the chip. Oh, that's interesting. Okay, let's wait for it to reboot again. I can type things for a little bit. So it is actually responding and doing some things. I can send it data. It just crashes halfway through. That's probably going to be a hard problem to solve, but like I say, for another day. Thanks for joining. I don't know when I'll stream next. I might announce it, I might not. we just have to get past this crashing problem, and then we'll have code running. I mean, we have code running. We just have to get past the crashing problem, and then we can turn our attention to the VMEbus stuff. So until then, have good times and be good things or something. Thanks for joining. Bye.